Yep.
All right. Okay. So, well, today's our last lecture. I really don't have a whole lot to talk about, except that I'm making the final exam right now. Okay, let's wait a little bit. I think people still coming in. Okay. All right. Maybe one more minute. See, John's here. Michael's here. Okay. See, a few people in. All righty. Okay, I think this is all most of us. Okay, this is recorded as well, so I don't think anything will be missing from the lecture. But today is our last lecture, and I don't really have a whole lot to talk about, except that I'm making the final exam, and there will be three problems so far, like all in solution format. That means there's no multiple choice, there's no filling the blank. It's just going to be straightforward full solution problems. Okay, now regarding the three problems, the first one will be deflection. So you might want to review how we calculate deflection, especially the differentiation between the sustained live load and the regular live load. Okay, so that is the key there. And for that problem, we're not going to ask you, most likely, we're not going to ask you to calculate the moment of inertia for the cross section. We probably would just give you that, so don't have to worry too much about it. But still, if you have time, please review that because if the section is very simple, for example, if it's just a rectangular section, we will not give the information about it for rectangular section. Okay, so that's the first problem. Now the second problem gonna be the development length, and I want you to review the two to three lectures we went through so far on the development length. Especially I recorded one lecture through the break. May want to dig it out and see how we solve one example problem. It's going to be very similar to that, except that we might ask you to compare the simplified approach and the conventional approach and to see which one is longer, which one is shorter, that kind of effect. Okay, so that is the second problem. The last but not least is the column analysis. So we're not going to ask you to do any design. We didn't have the time to talk about it, but we will ask you to check the capacity of the column, like the example we went through in the lectures. And also in the previous lecture, I draw the drawing from homework. We have three-layer reinforcement. So the final is going to have a section similar to that section, okay? Not exactly the same, but similar to that, all right? So you need to know how to calculate the axial forces, the bending moment, given the strain distribution on that section. So those has to be taken into consideration. Now we talked about two examples. The first one is full soft example. The second one is half soft, meaning I give you the equation, left the numbers, you need to fill them in. So if you haven't done so, please do that. And we showed you the last lecture, in the last lecture, we showed you the problem with three layers. I briefly talked about how to consider the extra layer. It's not difficult. Try it yourself. You still couldn't get it done, let me know. I can walk you through it. All right. So that is the three problems you're going to face in the final exam. The exam is going to happen on Tuesday from 3 to 6 p.m. The format will be the same format we've done for the second exam. It's going to be online. You get access to the file, start solving the problem. No communication allowed between students, and I can see if there's any similarity in the solution. So just don't do that, okay? Work on your own, and you have all the resources you need. And I'm pretty sure you can now find a solution from your homework and from the notes, but they're similar problems. So you can still employ the knowledge you obtain from the lectures. Okay. And apart from that, uh, I don't really have a whole lot of information on this course. I just feel very grateful for you guys being sticking with me for so long and bearing the pressure throughout the semester during this COVID thing. And I wish you good luck on the finals. And now I'm just gonna stay behind. If you have any question, you can ask or stay behind. We can chat a little bit, whatever you want. Okay. All right. Any questions, guys? Anything? We are good.
Bob, I got a question on the homework.
Yes, sir.
So I got the answer for number two.
Uh-huh.
The answer for number 1A,
Uh-huh.
that's just pure axial compression. I could not get that answer.
Okay. So first of
And
all, for that one, we have two parts, right? One is for the concrete part, the other for the steel part. And there's a K3 strength, well, concrete reduction factor 0.85. Did you apply it?
yeah, so I
Okay.
did. So the equation that I pulled out was 0.85 times the force of concrete, and then I did AG minus
Yes,
the
AST.
total, yeah, minus AST, and then I
Right.
added AST times FY,
Right.
and
And
that was
this is for PN, right? This is the maximum axial force, right?
yes.
Uh-huh. So did you apply the strength reduction factor 0.65 in front of it?
Yes. I
And
also did.
still you still
Yeah,
come up short?
I did not get the value that you guys computed for A.
That's a little bit weird. How much you're short? Like what's the difference there? Can you tell me the
About
number roughly?
about 300 kips off.
Oh, really? That's a big number.
And honestly, Bob, I also did the same thing for problem number
Uh-huh.
3A,
Uh-huh.
and I got the same thing wrong. So,
I see. Do you mind maybe email me the solution you have? Because I mean,
yeah,
we might have some typos in the answer we provided because it's been changed quite a bit, but I just want to see your solution, then I know if you made a mistake or there's a typo in the solutions.
yeah. I mean, like I said, like I worked through the
Uh-huh.
homework, and the only problem that I was really like confused and stuck on was problem number 3.
I
I
see.
tried started on it, and then I got confused on it, so I stopped on it. So.
So that's the last problem with the
Yeah,
column
that's
analysis, right?
yeah. And
Okay.
on problem number 3A, I mean the first part was basically the pure axial compression, and I applied the same equation to that problem, and I still got this wrong answer.
Uh-huh.
And I even applied phi of 0.65, and I
Uh-huh.
still came up with the wrong answer. And on that one, I'm about 200 off on that one too.
I see. I think you want to just send me the worked out solution from your side on A, and I'll take a look at it. I mean, there might be a typo in the correct answer. I'm not sure about it, but
Okay.
let me take a look at it and let you know. How about that?
Okay, perfect.
Uh-huh.
But then yeah, I don't know if you want to do it today or next week sometime. Could we just walk through problem number 3? I don't know,
Yeah, yeah,
kind of.
yeah, definitely. I think you can send me like right now so I can take a quick look at it. Maybe we can do it either today or tomorrow. Let's just wrap it up though.
Yeah, I mean, I'll let me send you my work right now.
Right, right, right. I'm pretty sure at this point either there's algebra mistake or there's some typo in the correct answer, but I didn't know which is which. So once I see that, I can make a decision real quick. All right. Okay. Anything else from the other guys? Bryce, Dalton, Lucas, any question from you guys?
None for me.
Okay.
No,
Dalton, you
none.
good? Okay, good. All right. Well, Mike, send me the worked out solution. Let me take a look at it. And how's your, let me just stop recording.